Okay, inverse variation. So it says, recall from Algebra 1 that if two variables x and y show direct variation, then y is equal to k times x for some non-zero number k. So in Algebra 1, you guys learned about direct variation, which is y is equal to kx. So notice this is y is equal to k times x. So the operation here is multiply. We're going to learn about inverse variation. And inverse variation has the formula y is equal to k divided by x. So notice that it's the opposite of direct variation. So instead of multiply, we're dividing. K is a constant. And remember, a constant is always a number, whether that's 1, 2, 3, 4, 5, etc. If the constant k of variation, then y is said to vary inversely. Okay. You'll see this in the examples that when it's talking about the problem, it will say the variables x and y vary inversely. It won't say that there is an inverse variation. So it's just important to know that phrase there, vary inversely. So looking at the example, we have the variables x and y vary inversely, and y is equal to 15 when x is equal to 1/3. So we first write our equation for the inverse variation, which is y is equal to k over x, and then we're going to plug in y and x so we can solve for k. So this gives us 15 is equal to k divided by 1/3. And then in order to get the k by itself, we're going to multiply both sides by the denominator. So in this case, we're multiplying both sides by 1/3. What happens is that these 1/3s cancel, and we're left with k is equal to 15 times 1/3, which is 5. Once we find our k value, we now have our new equation, y is equal to 5 over x. We're going to use this new equation that we found to solve part B of example 1. So we have y is equal to 5 over x, and it says find y when x is equal to -10. So instead of x, I'm going to write -10. So y is equal to 5 over -10, which means y is equal to -1/2, and that's my answer. So we're going to do the same process in example 2 and example 3. Example 2, the variables x and y vary inversely, and x is equal to 8 when y is equal to -1. So we first write the formula, y is equal to k over x. Y is given to us as -1, so this is -1 is equal to k over 8. And then to get k by itself, we're going to multiply both sides by 8. So we get k is equal to -1 times 8, which is -8. So that means we have the new equation of y is equal to -8 over x. And then we're going to use that new equation to solve part B. So we have y is equal to -8 over x, and it wants us to find y when x is equal to -2. So that means I have y is equal to -8 over -2, which means I have y is equal to 4. Okay, last example. Variables x and y vary inversely, and x is equal to 24 when y is equal to -3. So we have y is equal to k over x. Now we're going to plug in y and x, so -3 is equal to k over 24. We're going to multiply both sides by 24 to get k by itself, which means we have k is equal to -3 times 24, which is -72. So I have the equation y is equal to -72 over x. And I'm going to use this equation to solve part B. So y is equal to negative 72 over x. It says find x when y is equal to negative 9. So now instead of plugging in for x, I'm plugging in for y. So I have negative 9 is equal to negative 72 over x. I need to get the x out of the denominator, so I'm going to multiply both sides by x. Which means I have negative 9x is equal to negative 72. Divide by negative 9 to get x by itself. I'm left with x is equal to 8.